Something that I think is good, there's like 3 areas to focus on. The first one to me is helping educate folks on what is chaos engineering and sometimes like what is reliability engineering, like what even is SRE. And you've got to do that first, like so that people understand why we're doing this work. Then the next step to me is like trying to figure out like how do we move towards a culture of reliability where we're injecting failure. And a lot of the time for that, I would say you want to think about, are we going to do this as like a centralized team that's doing all of this work, like all of this chaos engineering work? Or do we want to do it more like self-service where we just make it available to everybody?
Welcome to the Software Misadventures podcast, where we sit down with software and DevOps experts to hear their stories from the trenches about how software breaks in production. We are your hosts, Ronak, Austin, and Guang. We've seen firsthand how stressful it is when something breaks in production, but it's the best opportunity to learn about a system more deeply. When most of us started in this field, we didn't really know what to expect, and wish there were more resources on how veteran engineers overcame the daunting task of debugging complex systems. In these conversations, we discuss the principles and practical tips to build resilient software, as well as advice to grow as technical leaders.
Hello everyone, this is Ronak here. In this episode, Guang and I speak with Tammy Bryant Butow. Tammy is a Principal SRE at Gremlin, where she works on chaos engineering. She previously led SRE teams at Dropbox, responsible for databases and storage systems used by over 500 million customers. Prior to this, Tammy worked at DigitalOcean and one of Australia's largest banks in security, product, and infrastructure engineering. We had a great time speaking with Tammy. We discuss how her curiosity led her to the world of infrastructure engineering, an outage from her early days where a core switch took down half the data center, her experience running a disaster recovery test, and how it taught her about the importance of injecting failures into a system to make it more resilient. We also touch on advanced failure injection techniques, how chaos engineering is evolving, and how extreme sports help Tammy keep calm under pressure. Lastly, Tammy has some great advice for teams looking to get started with chaos engineering. Please enjoy this super educational and highly entertaining conversation with Tammy Bryant Butow.
Hi, Tammy. I'm super excited to have you with us today. Welcome to the show.
Thanks so much for having me. Great to be here.
I noticed that you were doing full stack software engineering before doubling down on SRE. So what made you kind of decide to join the dark side and focus on infrastructure engineering?
Yeah, it's actually a really fun story. So I always loved computers, like since I was super little, had a computer, had the internet since I was like 11. But the big thing that happened to me was, I finished school, went to university, studied computing, computer science, did programming, loved it. I really loved everything though. So I was like trying to figure out what would I like to focus on. And then I got my first job out of university college at the National Australia Bank in their like graduate programmer job, like rotation that they have. And so what they do is they put you in like 3 different teams. And that was pretty cool for me because I thought then I'll get to try a bunch of different things out and, see what I really wanted to double down on. And my first team I went on was mortgage broking. That was like super cool because it was very critical systems. But I realized every single time they were like, can you build some new features on the front end? Can you also do some business logic work? Can you fix some issues with the database? Can you fix some issues with the load balancer? Can you be on call? It was like do everything. And I realized that like every time I tried to build anything on the front end, I had to go back a layer. And I was like, okay, like this isn't working. It's like super slow. Why is it not working? Oh, like the middle tier is really bad. Wait, actually, it's like the SQL queries. Can I fix those? No, the database structure is like really bad. And then there was issues with load balancing too. So I just like would go back and back and back. And then I was like going all the way to the hardware. Like what kind of hardware is this running on? And that's just the kind of person that I am. I'm like, I just can't stop going all the way back to the very like bottom level. Like, how is this data center powered? Like, and I went and visited the data center to learn more about it. But that's just me. Like, I'm curious. And I realized that it's like really hard to make things amazing on the front if they're really not very great on the back. So you kind of have to fix the back end first a lot of the time. Yeah, that's why.
And now you're a Principal SRE at Gremlin.
Yeah.
What does a day in your life look like as a Principal SRE?
Yeah, it's really varied. Like I've been at Gremlin for 3 years now, so I've done a lot of different things. I joined as the 9th employee, and I've done a lot of things over the years, like normal things like you would imagine. We are primarily on AWS. We've got a really nice like layout. We try and like in terms of architecture, we also use a lot of new services. So when AWS releases a new service, we try and be like at the forefront. That was one of the reasons I liked joining Gremlin, because we weren't like, we're just going to stick with old stuff that we know well. Gremlin's like written in Rust. We use like SQS, SNS. We've used Lambdas for some stuff. Like, so that's been really fun. Like I wanted to join Gremlin. One of the reasons was I'd always actually worked on-prem, because like Dropbox is on-prem, DigitalOcean's on-prem, National Australia Bank's on-prem. I worked on a little AWS project, but it was always like building the cloud or cloud sort of related products for other people. And Gremlin was founded by two engineers that worked at AWS, like building AWS. And I was like, that's awesome. If I want to learn about AWS, I'll go work with them. And so, yeah, like I've learned so much from them about how to build like reliable, scalable systems on AWS, which was like a whole new area for me. So actually, like, even though I'm a, principal SRE, like I'd say like the last 3 years, I've just learned so much about building reliable systems on AWS, and especially by doing a lot of chaos engineering, failure injection. Obviously, I've been on call over the years, but we really don't have, I've like pretty much never got paged. I think in my first year, I got paged like once, like it was like nothing. And that's very different. In the past, I used to get paged hundreds of times a week, until we would fix issues. And also you got the advantage of joining a startup when it's small, being the 9th employee. It's like super early on, right? Like Gremlin just existed. We just got a web UI, because before it was like a command line tool for the agent. It's all like really new. We did a big migration to React. And that was something that happened over the years. But yeah, lots of cool stuff. I'd say my day-to-day, a lot of it's now actually helping other people understand like how to build reliable systems, how to do chaos engineering, how to do failure injection, and also thinking through like strategy and future work, which is something I'm really excited about. Like, where is SRE heading? Where is chaos engineering going? Like, what are the new platforms that are coming out in the future? What are some easier ways that we can get big reliability wins, like instead of just doing it like the same way that we've always done it? Because I have a few tricks up my sleeve, but I like to always think of new ways too. So yeah, that's me.
That's really cool, kind of moving away from doing on-prem to cloud. What was your biggest pleasant or unpleasant surprise during that move?
I mean, it was really different than I expected. Like, I honestly thought it was going to be a lot more complicated and difficult because, like, no offense to AWS, but it's like there's a lot of services and everything's really different. And it felt like before I started to do it, there was just like a lot. Like, it was like, whoa, there's like a lot of services and a lot of things to learn. And like, it didn't seem like the pieces all connected really well together, right, to me. But now it doesn't feel like that at all because I've done it for 3 years. So now I just feel like, oh yeah, just grab this bit, put it over here, grab that, do that. It's all actually been very easy to do. And then injecting failure enables you to see like what happens when systems don't work well together, right? Like, and I like a lot of the features, but I've learned like the ins and outs of how they don't work. Like, auto scaling, that's a really cool product that AWS built. But like, I've also seen a lot of outages related to auto scaling because like of configuration issues and like throttling problems there. And so just, I'm at that level where I'm going into that next layer of like, how can you actually make sure that this is reliable, but like in the really, really like tiny little details. With on-prem, it's totally different. Like, I was focused on such different stuff like hardware, performance tuning, firmware upgrades, kernel versions. I mean, like, I'm just not looking at, kernel versions for EC2. That's like, there's just different things that I just don't even do anymore. Or picking hardware, I would be part of like buying hardware decisions. What hardware do we want to buy for our databases? Let's look at all the options. Let's have like hardware vendors come in and demo to us and like pick the best hardware and do capacity planning. It's like totally different. You still have to do it, but I don't have to do it like, we have to buy this hardware and get it shipped to the US and then put it in our data centers, buy more data center space, like just a lot of projects that you don't do. But I honestly love on-prem work. Like, I really love it. It's super fun and cool. Like, I know you do it at LinkedIn, and then you also have like Azure as well with Microsoft. So it's cool. You get to do both. Like, and I think it's good. yeah.
Yeah, LinkedIn is actually in the process of migrating to Azure. And some of the challenges that you're describing is like there's a set of problems that you don't have to think about anymore.
Exactly.
But then there is a whole new set of problems.
I know. That's exactly what happened to me. Like, yeah. And then you're like, oh, wow, these are really different problems than I solved before. And like, I'd never solved those problems. So it's like learning totally from scratch.
Yeah.
Yeah.
And Gremlin is a chaos engineering company. How did you get into chaos engineering?
So I started back at the National Australia Bank. And one of the things that they told me that I had to do when I first started, they were like, alrighty, so we're volunteering you to run our disaster recovery testing. And that's like DRTs, they call them. And basically they were like, so for mortgage broking, you have to make sure that it fails over from one data center to another. And you've got to go to this like secret location on the weekend. Someone's going to come around and like ask you to fail over your system, and then they're going to check that it actually worked. And if it doesn't work, then they're going to like mark it down on a piece of paper, and then you'll have to fix everything and then test it again in a quarter. I was like, wow, this is like super serious. Like, and I just graduated too. So I was like, do I even know how to do this work? Oh my goodness. Like, but my boss was like, you know, I think you're going to be good at this. So he just like volunteered me for it, which is really cool. And, yeah, he was a great boss. I was lucky to have an awesome boss coming out of university. Gave me a lot of good opportunities. And yeah, I went to this like secret unmarked building, did the failover exercise, passed the first time because you do a lot of work to prep, a lot of failure injection on purpose proactively, and making sure that you're like injecting that chaos that you'll pass that region failover. And the big thing too is like we had to do it for compliance reasons, right? Like because you're a bank, so you have to pass these big, massive exercises. And I did so many over the next 6 years. And sometimes I passed, sometimes I failed. But it was like on big systems, mortgage broking, internet banking, foreign exchange trading. So like I love that, like working on critical systems. And then moved to America, worked at DigitalOcean. And I was like, oh, I think the easiest way for us to learn about really complex system is to inject failure. Still believe that. And DigitalOcean was like 14 data centers. So it's like massive scale for on-prem. Mm-hmm. And like, you know, yeah, like things go wrong. Failure happens. Like you need to be able to be ready to handle it. It's like such a cool like scale too, like having that many data centers. It was really fun. And we did a lot of cool work. First, we started with just like drills, you know, kind of like tabletop exercises. And then you just think through what else can you do? You obviously want to try and inject failure. That's the best way to do it. And then at Dropbox, I went there and did it straight away. Like in my first 3 months, I reduced incidents by 10x with my team, the databases team, by injecting failure on purpose to identify those areas of like weakness that we needed to fix. And then we just did a like reliability sprint. So 2 weeks dedicated just to reliability, even though we are SREs and obviously you do reliability. But we were like, nobody can book meetings with us. We're focused on this. Like we want to fix all these things. We're just going to work really, really fast and hard. And we came out of it and it was awesome. Like we just never were as bad. For the next 12 months, we never had a high severity incident. So yeah, that was really cool. But that's how I got started, and it's just been such a fun journey. I've learned a lot over the years.
Nice. I remember my first exposure to the concept, I think, was watching a talk at AWS reInvent where the Netflix people were talking about the Chaos Gorilla, Chaos Monkey, and just being sort of mesmerized by, you know, when they show the graphic of like doing a live sort of, the argument and redirecting. Yeah. I'm curious, how does sort of cloud or the massive adoption of cloud kind of play into this? On one hand, I can definitely see, right, like, because these cloud providers kind of abstract more and more of these things away such that you don't have to worry about it. But then on the other hand, because of more abstraction, you can move faster. So there's more errors and there's more room for failures. So there's more of a need to kind of preemptively test. I'm curious to kind of get your thoughts around that.
That's a great question. Like I get asked that a lot as well. And like there's two things that come to mind. One is, you know, moving to the cloud. A lot of folks think like, yeah, this is going to be easy. I won't have to worry about reliability. It'll happen out of the box. But like that totally doesn't happen. So don't think that. Definitely it's not going to be as easy as you think. Like, and I think as SREs, we know that going into it, you totally know that, right? But a lot of folks don't have that reliability background. And so a lot of what I've been doing actually is helping people create like an understanding or culture of reliability too. because that's really important. Like, why is reliability important to us? You know, how do we show that we care about it by demonstrating like that and doing actual work to, you know, be proactive and focus on reliability? And specifically, like, so if we look at, you know, Kubernetes, and if you think about that, there's like a lot of outages reported just for Kubernetes on the cloud, like lots. Like there's a whole GitHub repo.
Yeah.
Like, yeah, k8s.af. If you check that out, there's like tons of outages. So, and I did some work, like research to analyze those outages. That's like something I do for fun. I'm like a super nerd. And, and I created this diagram, and it was like, wow, like, you know, 25% of those outages were related to just CPU issues, like spiking CPU or CPU throttling, which is like, you know, you're like, wow. Whoa, as an SRE, like that's crazy. And then the other thing was about just clusters being unavailable. So like that's just, you know, shutdown or unavailable machines, like an unavailable node usually, maybe not even at the pod level, which is more complicated.
Yeah.
But yeah, looking at that, you just go, wow, like we still have a lot of basic things to fix. Like, you know, we can't handle CPU spiking and like shutdown of nodes with Kubernetes, which is supposed to be reliable. Like that's kind of where we are right now as an industry. And like, obviously in like 10 years we'll be somewhere way better, but it's still just the beginning phases. That's what I really think.
Yeah, it's interesting. What were the other kind of failures you saw with like patterns with Kubernetes failures in general in the cloud?
Yeah, it's really interesting. Like so that was like the, you know, half of it was CPU and hosts or nodes going away. And a lot of that has to do with like how you can set up your clusters, like because there's limitations there around like AZs and regions, and that can cause outages. Yeah, it's like those fine little details are what you need to look into. And there have been outages of like 2 regions at the same time, you know, so just knowing that is something you've got to prepare for. And that has caused people to lose a lot of money because, like, if folks don't know, like at some enterprise companies, if you have an outage, you might have to pay a fine to like your customers, like an SLA downtime fine. It can be like millions of dollars in some cases. So it's like, you know, that's why SRE teams are so important in this work. You save like lots of money for a company as well from just that perspective. And then the other side of the issues were actually mostly related to like networking and resources. But when you think about networking, DNS is like a big one, you know, that's like always a big one that has failures. Yeah.
If you don't know what it is, it's probably DNS.
Exactly. It causes a lot of issues. You know, and you can do like redundant DNS or like have more reliable DNS infrastructure by having a backup and stuff like that. But a lot of folks don't do that. And then the other area for networking issues is usually like latency or packet loss. And that's kind of, you know, yeah, just being able to say, what happens if my system experiences latency? The first thing I always think is like, would we know? Like, and then do we have good tools to be able to identify that? And can we like pinpoint where the actual problem is? And then can we remove that problem like from the path? And I think like it's really good like superpower for an SRE to understand networking. You know, it's like very handy. Like whenever I've worked anywhere, I was always like super good friends with the network engineering team, and they're like awesome. You know, I'm like, what tools do you have? Can I have access to your tools? And they're like, yeah, sure. They'd like let me log into Thousand Eyes, and I would like be like, wow, it's like, this is a dream. Like I can see the network diagram. And then they taught me all about peering and how we would like, you know, make the network a lot better. And yeah, like that's a really cool thing to focus on, because you can improve your system, you know, a lot, but you need to be able to work with other teams to do that, right? Like that's a big thing. Yeah.
Yeah, absolutely. I think networking part, it gets more complex with now overlay networks and containers in there, where every Linux machine becomes a router of sorts.
Exactly.
So it's like so many layers of abstractions you have to understand.
Yeah, you're so right, Ronak. And then you can have, latency between all those different layers and, or, you know, just like total packet loss or a little bit of packet loss.
Yeah.
Job creation, right?
Yeah.
So you at Dropbox, you were an engineering manager. Do you feel your experiences, I guess maybe the question is kind of based on this post I read from Charity Majors, like I think a while back, talking about sort of straddling between the IC track and the management track. It's very hard to do both well at the same time. So, but you also don't want to, you know, get too far away from one another. So then do you feel like your experience in managing a team kind of helps you in this like more like a leadership role as an IC?
Yeah, definitely. Like I've read that post too, and I think it's really good. Like I've definitely flipped between the two roles over time. So, you know, like, yeah, obviously most folks probably start out as an IC, like I sure did. And then, you know, you get your first opportunity. My first opportunity was to lead like an intern, which was really cool. And they were like, can you help lead this intern and guide them for their internship? And then after that, and I count that as leadership experience, right? Like if you're told to lead an intern, then you are a manager for that intern. And then after that, I was leading a new grad. And so I had like one person and then gradually led more and more folks. But then I decided I wanted to go back to IC work. And this is still like at the National Australia Bank. So I went back to IC work. But after, it's kind of like the way to describe it is like, when you first become a manager, managing people, you like look behind this red curtain, you like open it up and you're like, whoa, this is what they care about. Like I like did not know how I was being measured for performance or like what people thought was important to, you know, for me to do until like I didn't know what a roundtable discussion was for performance conversations. Like there's all this stuff that like you can't imagine what it looks like until you see it. And the only way to see it is to become a manager. And like it's hard to describe it to people, but when I would go in, I remember my first roundtable after a performance review sort of cycle so well, like people saying, I think this engineer should get promoted because they delivered this and this. Actually, no, I think this one should get promoted more and first and like have a bigger pay rise because they delivered this other project, which was much more important and helped all these other teams. And like, I just didn't know before that because no one had explained to me like how we were being assessed. And so you're kind of just like trying to do your best work based on what your manager tells you. But then going into that room, I was like, oh, now I know how to, you know, really do well at my job. And it definitely helps. So like I tell everyone, like, if you can have a stint as a manager, just do it. So you can like see behind the curtain and be like, okay, now I get it.
At least you would know how the system works then.
Yeah, totally. And like as engineers, we love to know how the system works, right? Like you're like curious and you want to understand it and just even doing it for 3 months, it's really good. I wish there was an easier way to just like understand it and see, but yeah, it's a good thing to just do it. I'll recommend it for everyone.
So when you became a manager, did you miss some of the IC work that you did? Because a lot of your time would then go into people management.
No, because like I started really small with leadership. So, and I recommend that as well. Like I started with leading one person, one engineer, and he was a new grad and he was like super smart and switched on. And I would just help him with, it was very much more like I would say like being a tech lead manager, you know, so having him and, you know, mentoring him, doing one-on-ones, doing his performance reviews, figuring out what work he could deliver for the company and like assigning him to projects. You kind of have to like be like, my engineer can work on all these things, like, like shopping around for projects and stuff. But that's how it works in a bank. It's really different. Yeah. And they have like internal charge codes for projects. It's like really different. But yeah, when we did that, most of my work was actually with him, code review, like architecture discussions. Like it's very technical because he was new to industry and he needed to learn a lot of that. And then after that, I managed like, you know, 2 people. So still like had a lot of time to do IC work and I had IC projects assigned to me as well. And then I went actually when I was at DigitalOcean, I managed like 33 people at my like highest points. So that was like,
that's a lot.
IC work. Yeah, that was a big team. And I was having like 15-minute one-on-ones every 2 weeks with my team. Like I didn't even have the ability to meet all of them enough. But then we ended up scaling that out. But that's like startup life, you know, you grow so fast and eventually hire managers. But I always knew that was way too high. At Dropbox, my largest team was 14 people across like database and block storage, Magic Pocket at the same time, which was like fine. That was really cool. Like, and I think, I know I was just involved in a lot of technical conversations and I did do some IC work. So I suppose I'm like someone that can never totally be away from what we're doing because I feel like you wouldn't be very good at your job, you know, like I was involved in picking like what firmware version we should use in the kernel, like discussions and hardware. And, you know, I was the one doing the chaos engineering experiments, even though I was managing the teams. Like I was doing a lot of the failure injection, but more as like a validation for my team. Like, all right, I'm going to like fail the system. Is it ready, guys?
Yeah.
Like, yeah, it's ready. Let's do it. Boom. Okay, cool. It survived. Like we did great. Or like, oh no, like we identified some issues. Let's fix them. But yeah, I'm lucky to have been, to have worked with so many awesome engineers. I think that's like, as a manager, when you have an amazing team, you just are like, wow, like I get to work with all of these folks every day. Like that's like super inspiring. Like a lot of great people I've worked with.
Awesome. Like when you have manager who's also getting into the technical details, some of the managers might hate me for saying this, but they get a lot of street cred from their entire team because hey, I know my manager understands all these details. It's not just like about the eventual goal, but also what it takes to get there.
Yeah, and that's what I think is really important. Like, say you've got a project, like this is just a really simple example, but we had to do this database migration project, and I like looked at all of the tables, understood the schema. I interviewed every engineer that had worked on all the different services that touch that database, because I was like, we need to migrate from MySQL to our new distributed data store. And I was like, I feel like this is going to be a big project. Like, I can't just be like, hey guys, I want you to deliver this in 6 months, without looking into it. That'd be crazy. And so then I did all these interviews and looked at the code and understood it, looked into what data was even there, tried to think through, could we just like get rid of these tables, or do we actually need to migrate them over? Like talk to people about that. So like really looking into the details. And then, when we looked at it, like I was like, I think this is going to be like over 100 engineers and it's going to take like over 12 months. And that's what I put forward, and that's what it ended up being, but it was like, that's the thing too. I think a great manager has to talk to their team and like their engineers and ask, hey, this is a big project. Like, what do you think are going to be the hardest things for us? What's going to, take us time? Do you think we're going to come across any issues here? Like, let's chat about it. Like, let's get into a room and draw out a whiteboard diagram of the architecture. But I think it's also like, yeah, the engineering manager has to be interested in that. But it's like, be passionate, have purpose, but also be like curious. And you can't fake that, right? Like, I feel like you can't fake it. So
Yep. Could not agree more with that. So we've been talking about some of the outages in the public cloud, and I actually want to touch that. But before we get there, you were managing the storage, some of the storage teams at Dropbox, and managing storage systems, in my opinion, are hard. Anyone who does that would attest to it. So we love discussing some of the production outages and lessons learned on this show. Are there any such outages that you could share with us today?
Yeah, totally. So yeah, definitely agree that, managing anything that is related to data is hard and scary, right? Like it just has to be, because it's critical data. And then you always think through like, what if we lost our data? Then it would be gone forever and you can't just get it back. Like if you don't even have backups or something, or there's no like extra layers there. So that's why it's so scary. And also just around consistency issues. Like, that's the other thing. So I always thought this, like engineers who are going to work on storage databases, it's like, whoa, like you got to be brave for that work. That's like, it's a big thing. It is. It's really like that. And things change so fast, and, a lot of teams depend on you because, if you're at the data layer, like pretty much every team needs that data. So you have a lot of internal customers and you need to make it available, like always reliable and like accurate. And so, yeah, that's a big thing. And then, but in terms of outages, everywhere that I've worked over the years, pretty much except Gremlin, like knock wood, has had like a data related outage. And like right before I joined Dropbox, there's like a big outage that had happened. And if you look up like, Dropbox, outage, I think it was like, when was it? 2014, something like that. There was like 3-day outage related to the databases. And so, that's a big outage.
That's a long one.
Down for 3 days. And it took a long time to get everything back up and running. And it was just from like human error. Like, somebody did something that they didn't mean to do, and there wasn't enough guardrails in place. And that's why that ended up happening. So it was just like a thing where, of course, like after that, you put in the guardrails in place and you it's just like they should have been there in the first place and they weren't there. But a big part of what I did when I joined was to try and think through, like, how can we make this better? Like, what can we do to, not be in that situation again? Like, work with the team to, like, put in all these different guardrails in place, lock down, like, the ability to do certain actions. That's really important. But I think, like, even before that, that's what I'd say with databases. It's always a thing where you go, like, you only want some people to have access to those that really are careful and, they're, like, typing like this, like, oh, my goodness. Like,
yeah.
It's like a big thing, like, when you're doing something. So you don't want to, like, most people don't want access if they don't know what they, what's going to happen or something like that. You really want to limit it. And I think that's better rather than just having it available to everyone. Yeah.
Oh, I remember one of my colleagues, we were running a maintenance on a database, and one of my colleagues was like, I want you to look over my shoulder to see every command I type before I enter. Let's double check the exact thing.
Yeah.
And then we'll hit enter on this production system. Like, I can relate to that.
That's a good way to do it. That's a great way, though, having that person peer review you running those really important commands. Because that's the thing, like, you check with others, but it's like, it's that moment when you run it. Like, that's like the moment that counts. And, like, that's a great tip to just... It's normal. I would do that. I would be like, hey, can you check that this is right? Like, I'd usually send it in Slack. I'm going to run this. Does this look good? Yep, that looks good. Or like, oh, maybe you could improve it by changing it to be this. All right, cool. Now I'm going to run it. I've definitely said, hey, does this look good? Look good? Okay, yep, that's good. Do it. All right, cool.
Yeah.
And then you get, more confident, but you don't want to be too confident that you make mistakes. So it's like always good to like actually just take that time to check it. And then, so that's like data related outages, and there's plenty of others, but other really interesting outages too, like from working on-prem, just like a lot of different types of failures caused by, one was like core switches, like took down half a data center.
Do you know more? Do you remember details about this one where a core switch took down like half the data center?
Yeah. So, I mean, there was a lot of problems that I've worked on in the past where it could be like just a configuration problem or an upgrade issue, or just like, even like I've worked on outages where there was like power failure within the data center, where that happens too, right? And then, and then a lot of outages related to firmware as well at that next level up. So I think like, the way that I always think about it now is like everything's going to break in all these different ways. And then you just have to really try and build in your failover mechanisms and think through like what would happen if this failed in this way. And it is really different, like on-prem versus the cloud. So at least you don't have to think through like, core switches, like with the cloud.
That is definitely one big advantage of moving to the cloud. So I want to talk about some of the cloud stuff. Before we do that, you mentioned like when you went to Dropbox, one of the first responsibilities was to kind of harden these systems. Now, one of the ways, as you mentioned, to do that is you identify these failures, or you inject failures and do these experiments in a more controlled environment. Yeah. Personally, I feel like when it comes to orchestrating stateless systems, we have gotten much farther as an industry. But when it comes to stateful, everything is so specific. So even when you're doing these like chaos engineering experiments on stateful systems to identify these failures, what kind of challenges did you see in the past, or what kind of challenges do you see today to kind of run those on stateful systems?
Yeah. So definitely agree there. Like when we were thinking about what to run as our first, chaos engineering experiments for the stateful systems. So for us, it was like, thousands of MySQL machines, and then also some proxy machines too, some like hosts running a proxy for the database, cache, like memcache as well. That was like the main area we started. We just like, I think a good thing to do is to get into a room and brainstorm like different types of experiments you could run, like, and using the scientific method, like what is our hypothesis? What kind of failure do we want to inject? What do we expect is going to happen? And then like we ran it on staging first. Like we didn't start in production. We gradually worked towards production. It didn't take us that long, but like it was good to start in staging for sure. And the first ones that we decided to run were actually like process killer, which is like actually pretty advanced, like type of attack. Like not a lot of people use those. Like now that I work at Gremlin, I see tons of people using, practicing chaos engineering all over the world. And process killer for us, we were like, we really want to make sure that, and it's like very much based on our specific circumstances. So that's why it's important to get in a room and talk it through. So we were like, we want to make sure if my SQL dies, then the entire machine is like reaped away, it's taken away, and we get a fresh one. Like, we don't want anything else to happen. That's exactly what we want to happen. Like, give us a fresh new machine. It should already be in the free pool of machines. So it should already be pre-built, and then it should just go into the cluster and everything should be great. Like, that's what we want to test. And then we were like, we sort of have a feeling that sometimes that process doesn't happen as fast on certain days of the week due to like networking load. So we were like, let's do it on Monday morning versus like Friday night, and then like see if it changes. And it did change. We like saw it. Sometimes it would be super fast, other times really long. So you want to like know all of that, right? Then we started to take much more detailed metrics of like how long does it take for us to replace machines if the process dies. And like, this was like a really detailed project that went on for like several months, and then we just kept getting better. But that whole time we were like injecting the failure to learn from it, and then making improvements, going to talk to the networking team, sharing our data and results with them, figuring out what we could do to make it faster. We realized at one point we were being throttled by the networking team. There's like QoS, you can like pick who gets what traffic, and like just some tiny portion of throttling was happening, but not at a large scale. So we like resolved that. So yeah, there's just it's like, you got to be in that level of detail. Like, I'm going to be, comfortable climbing into that detail and figuring things out.
Yeah, totally. So one thing that engineers like is numbers and metrics. Once you did all these experiments, of course, it would change over time, but over like the first span of this 6 months to a year, were you able to identify some of the low-hanging fruits to say, we caught these in staging or in production, and these were just ticking bombs that would have taken down the system?
Yeah, so it's actually really interesting. I love that topic. So yeah, I'm really big fan of metrics, like everyone is. And one thing that I really loved when I joined Dropbox was that we had these automated metric emails that got sent. And so I think you do it at LinkedIn as well. I've heard that like every day there's like automated emails that get sent out with like top metrics for the systems. Yeah, I think that's awesome. Like, I hadn't seen that anywhere else that I'd worked, but it's also, for us, it was color coded. It would be like red if it was below expected and green if it was like above expected. And it's like very easy for everyone to just sign up and get those emails for every system that's critical. And then that's cool because everyone sees your system getting better. Like, your system starts to be like super green and it used to be really red. And like, hey, you guys like fixing things over there? What's going on? So that's a really cool way to do it. It's like really nice. And the other thing was just like, I'm actually big on creating presentations like based on your data and trying to tell a story around it. Like, hey, we identified these problems. This was the data set that we first looked at. We identified that these would be key areas to fix. And then this is what we did to fix it. And these are our results, like afterwards, like telling that story. And that really helped us a lot to get like buy-in. And other teams then were like, can you show us how to do this? And then we started to help them. And then we built tools for them to do it themselves. So it was more self-service. Like, we built a dashboard called Scout that was like an internal tool. So any engineer across the company could add their like PagerDuty service ID and then see the metrics for their incidents. But I'm actually like, I'm a little bit different, that the way that I like to pick what problems to solve is I'm like, let's go after the big problems, like the big fish, the ones where it's like, if we fix this problem, then it's going to knock out like 80% of our issues, like thinking about it from Pareto principle, like that sort of 80-20 rule. And that's always like scary to folks a lot of the time, but I think it's like more fun. And I'm like into extreme sports too. So like, it's like, let's go after the big one. Like, this one's really bad. Let's fix that. And they're like, oh, it's also like, that system that people are scared of, that no one wants to write code for because no one's written code for it for like 10 years. And they're like, oh my goodness. But yeah, I'm like, let's do it. Yeah. And then we would do that. We'd be like, let's go after that system, or let's decommission that like flaky thing, get rid of it. And it feels so awesome when you do it, Yeah, absolutely. I mean, once you get past all of that, it's like a threaded background of your head has just gone away now. Gone.
All this mental capacity has been freed up.
Yep, totally. You don't have to be thinking about it at all. You're like, we just removed this really bad part of the system and it's gone. Like, it feels so much better. Like, I think about it a lot. Like, say you live on this great street and there's one house that's like super ugly and like real smelly and bad and no one wants to go in there. It's like, that's like some of our systems. Like,
yes,
someone's got to get rid of it eventually. Like,
yeah.
And what extreme sports do you do? You're Australian, so I feel like that already sets the bar kind of high.
Yeah,
and when you say it's extreme sports, so
I like lots of stuff. Like, yeah, definitely, you know, everyone's into surfing. That's not so extreme, but definitely love skateboarding. And I used to go in like skateboarding competitions and got like sponsored as well. So yeah, I love that.
Wow.
Yeah, it's really fun. I've been doing that since I was little. And snowboarding, love that too. Dirt bikes, mountain bikes, like BMX. Like, I love like actually BMX jumping. That's like super fun, but also like very painful when you fall off. It's like the most painful, but also so fun to fly through the air. So it's like a trade-off.
I would argue that surfing is quite extreme, especially when you got sharks in the water. So
yeah, that's so funny.
Two things.
I've never had a shark issue. Like, I've been in the water when there was sharks, but I've never like, you know, and I've just gotten out. It was okay. Like, my worst surfing injury was like one time I was riding a wave and then got like right to the end of it and got, you know, sort of toppled over. And my board went flying up in the air and like came right down on my foot. And it was like so bad. Like, it like almost broke my foot.
That's painful.
So, it was so painful, but it sounds so funny because like you don't think that sort of a thing would happen, but yeah, it happened to me.
Well, you're very brave, Tammy, is what I would say. Go ahead.
I was going to say, I always invite everyone to come along too. So yeah, if you ever want to go surfing, snowboarding, skateboarding, we can give it a go.
I'll need some pep talk before we actually start doing that.
I love it.
I imagine some of your kind of interest in the extreme sports would also help with kind of preparing you mentally for dealing with production systems and things which are scary.
Yeah, that's something a lot of people don't understand, and they think that it seems weird when I tell them, like, visualize your system. They're like, what are you talking about? Like, I'm like, visualize it before you go on call. Like, just think through what could happen. But it's exactly right, you know, because, yeah, like, a lot of athletes do that, right? Like, if you read, like basketball athletes and stuff like that, professional folks, they'll visualize themselves, like, getting, you know, the ball in the hoop. And like being like, bam, like I did it before they do it. And there's like really good research that shows that helps you do it. And definitely you're going to visualize yourself doing a skateboard trick before you do it. Like, you spend a lot of time, we call it like, you know, you're like amping yourself up, getting ready for the trick and thinking through all the details. Like, where will I put my foot? How fast will I like move my foot? What direction? Like, you know, all these things. What's the wind like everything. Yeah. And so if you do that with systems, it makes it a lot easier as well. And it doesn't take that long, right? It's like you said, even with the example of what am I going to type when I'm running this command, like just taking the time to be patient and think it through, that's way better than like just like, you know, running off on your skateboard off the edge of the steps and being like, good luck, hope it works out. Like, you know, it's probably not going to work out.
No, well, hope is not a strategy, right?
No, exactly. No, not at all.
So you mentioned running chaos engineering experiments like science experiments of sort, where you have this hypothesis, you kind of think about the failure you want to inject, and then you have kind of an expectation of what should happen.
Yep.
Have there been instances where your hypothesis kind of went sideways, where you're like, I think this is what should happen, but a completely unrelated different thing happened to the system?
Yeah, like that actually, it didn't used to happen to me until more recently. So yeah, like when I was at Dropbox, it was always pretty much like sometimes we would learn something new, but it was more like the detail of how we could fix that problem in particular, like related to proxy chaos engineering, or like had different types of failure modes if you did like a hard shutdown or a really slow shutdown, like non-graceful, like hanging threads, stuff like that. But when I've been doing it recently, like over the last few years, especially, you know, with Kubernetes and on the cloud, definitely like seeing unexpected things. And a lot of it, I think, is around, you know, one is dependency analysis, like you said, because there's a lot more complexity. So it's like, well, I have containers, how many containers inside each pod? And then I have the pods, and then I have like all the orchestration on top of it. And then I've got multiple nodes. And even just doing something simple like saying, if I fail this service, I expect that this other service will fail, but I think everything else should be good. That's like really hard to guess now. Like, you're really like guessing a lot of the time because it's a super complex system. And I used to like do a thing where I would print out the code to like read the code of older systems I worked on that are more like monolith and, you're learning about a specific area.
Mm-hmm.
And it was easier to get how things connected. But now I think with distributed systems and, containerization, it's like way harder. So pretty much every time something unexpected happens, I'm like, why is that failing? Oh my goodness. Okay, let's look at the code and like see why this is a hard-coded dependency or like why is there a problem between these two services? Yeah.
Yeah, like microservices just makes this entire graph super hard.
I know. It's like a really complicated graph. There's like that's if you Google microservices death ball. It's like that.
I haven't Googled it, but I'm definitely going to do that after this chat.
Yeah, that's exactly what it feels like. When you look at that diagram, you're going to be like, oh my goodness. It's just like trying to draw the architecture diagram for microservices is like horrible.
Oh, yeah. Well, it's a work of art at the end, right?
That's a nice way to say it. I like that. Especially if you picked cool colors or something.
Yeah, exactly. So do you remember any of the weird things, any of the latest weird things you discovered in one of these experiments?
Yeah, so one actually has been around... So just like definitely around dependency analysis. And I think like there's something that we do a lot of work on when we're doing tests. So we're always trying to think through like what are new types of chaos engineering attacks that we should create or run. And I have like a list of like 60 plus that are like on my list of things that would be cool to have available. And so then with that, I'm always trying to think of like what different types of failure will I inject. But I think like lately, the ones that are most interesting to me is like sometimes I'll get to work on systems that are payments related. And that to me is really interesting when you see different failure modes there. But yeah, like that's going to be really different depending on different people, what they're doing and how they're processing their payments. But I feel like lately that's like just an interesting area. But it's probably because I worked in banking too. But if you think about it too, like you go, okay, what's going to happen with payments, how that could fail? There's all these different things. It's like the shopping cart process, the payment processing, sending the information back. Then it depends too if you're doing this via like credit card processing or something like PayPal or Stripe. And if you've ever worked on like PayPal related like checkout reliability issues, like PayPal has so many error codes. Like this is like a thing, like when you've worked on that, you're like, whoa, like it's like
I haven't,
massive... Yeah, you got to look up like PayPal error codes. This is like a huge like encyclopedia of error codes that you need to handle.
Oh, wow.
And they all mean different things, like person has not enough balance, or person's PayPal isn't working right now, or person's PayPal has been locked, or all these different stuff. And so then your system might not let people process anything. And then you could have like, yeah, just different outages related to payment providers. So I think to me that's like an area that I'm interested in particular. Yeah, just all the payments failures.
Makes sense. And with different payment providers, I assume it gets more complex because the error codes are different.
Yeah, exactly. And then you have to go out to a lot of third parties related to processing different types of payments and transactions. So you have to learn about all those different companies and what kind of information they give back. So yeah, like that's a whole interesting world that you learn about, and all those systems have to work crazy fast, right? Like that's that's why I think it's fun. It's like, wow, you're trying to process this like that, so the user doesn't realize, and now it's like, whoa, like sending that information everywhere.
Yeah. So we talked about Kubernetes a little bit. What are some of the patterns that you're seeing? Or some of the ways to inject failure in Kubernetes? I've seen some of your blogs around like doing site reliability engineering for Kubernetes, or some of the common failures that you referred to before. But what are the recent patterns that you're seeing that people could use to inject failures?
Yeah, like lately I've actually seen a lot of folks are using AKS. So this is like more and more popular now. I've seen like a huge spike in people using that. A lot of our customers use AKS. So I think that's really cool. And a lot of the time, like, folks will start on things that, maybe sound simple, but it's really not simple, like around region failover and making sure that, if one region goes away, what happens? My biggest tip there when folks are starting to do it though is like, a lot of folks will go, well, I'll just like shut down my cluster and see if it fails over to the other one, or I'll just shut down my nodes. But what I like to do is say, well, like, Gremlin, we have an attack called a black hole attack. And what that does is it makes it unavailable. So it's a networking attack. And instead of like tearing down a whole cluster or a whole region or like a ton of machines and then having to like build them back up again, that's like really time consuming and also can cause a lot of like unnecessary issues because like taking something down and bring it back up, that's like adding more opportunities for failure to happen. Yeah, so if you just do a black hole, then you're like, say, oh, let's just make this non-available for a period of time, whatever it is, the pod, the node, the whole cluster, and then turn it back on. And you could do it for like 60 seconds or 30 seconds, and it's just like gone, now it's back. And so I like to recommend that. Like, I think at the moment, we're still at a point where that's where folks have to focus on, is like building out really good architecture with your clusters and thinking about that too, like how many regions am I in, what happens if it fails, and just the configuration of how you've got it all set up as well. Yeah, I'd say that's my main tip. Once we're like more advanced, then I'll come back and be like, okay, now let's get ready for this.
Nice. So, my introduction to chaos engineering was very similar to Guang's actually when I saw that Chaos Monkey, and I saw like cool. the CPU exhaustion is like the hello world of chaos engineering experiments. But as you see like teams kind of maturing on their chaos engineering practices, what are some of the sophisticated practices that you've seen in the industry?
Yeah, so I'd say like one of the interesting things is like, where do folks get started with chaos engineering and thinking through like the use cases of chaos engineering? So the first one that a lot of folks start with is validating, monitoring, and alerting, which makes a lot of sense, right? Like kind of like as a smoke test. So do a CPU attack, check that fires, that you actually can see that in your monitoring. So say like in your dashboards. And then also to be able to validate monitoring and alerting for if an alert needs to fire because like you've breached an SLO. And I'm seeing a lot of people, which I think is cool, do like aspirational SLOs for new services that they're building. I think that's a great thing to do. And then being like, let's set up the alerts for them. Let's validate that works, that we actually get a page based on that. And I think that's really different to where what people were talking about in the past. But it's really connecting the dots between a lot of things that folks are focusing on, like SLOs and SLIs. And I like the idea of doing it all really automated. So at Gremlin, we built something called status checks, which enables you to first actually see, like, okay, what is my monitoring at now? Like, what is the current level for my system, like for whatever you're looking at, if it's a specific resource limit or something like that. Then run an attack in an automated way if that first check is okay, and then check back again and see if an alert fired or everything's still good. And if it's great, then still progress even more. So that's really cool. And then
that is pretty cool, actually.
Yeah. Like, and it's different, right? It's like, let's automate this. Like, let's tie in the monitoring and alerting into the automation. So it's like, check first, run it, check again. Yep, all good. Run it again, check. And then you can just have that running like on a cycle. And if it fails, then hey, something broke, like something unusual happened that we weren't expecting.
You're trying to see how far you can push a system actually.
Exactly. Yeah. Like, really pushing. That's a good thing. Like stress testing. Like sometimes people will think about chaos engineering like that. I'm like, yeah, that makes sense. You are trying to stress test your system. And the other thing I like to see lately is a lot of integrating chaos engineering into the CI/CD pipelines. Lots of folks are still using Jenkins, that's like still really popular. And I'm seeing them like run these attacks. Like you deploy your code to staging, automatically run a set of like a chaos gauntlet. Or sometimes folks call it a reliability blueprint, which is a set of scenarios that every piece of code like on new service needs to pass. And it's nice. It's like super automated. I passed my reliability blueprint. Now I'm good and I can go to production. And I think that's cool. And if you didn't pass, then you know why, right? It's not like strange to you. You can just go and like fix it and then be like, yep, cool. Now I should pass. Do it again. Passed. Great. Off we go.
Yeah, that's very interesting. Can you share like some of the attributes of what this reliability gauntlet would look like?
Yeah, sure. So something that we focus a lot on over probably the last year was the idea of like, let's go, okay, we have the idea of attacks. So say an attack is a process killer or a spike CPU or shut down a node or a pod. then what you want to do is think through like the scientific method. So what is my hypothesis? What is the attack or the failure I'm going to inject? What do I expect to see happen after? So what we did at Gremlin is we built something called scenarios, which is like you could have one or more attacks and like one or more attack types in one scenario. So it can get pretty complicated. And some of our customers have built it out that it's like, you know, there's over 100 scenarios that have to pass because it's like really complicated systems, where they have to meet a ton of compliance requirements.
Yeah, that is significant.
So if it's like a bank or a finance company, they have to also prove that their code and their services pass those scenarios now. It's like a check that it has to get through. And so that's like probably on the like most advanced complex sort of style of what I've seen. And then like probably what I also think is great too is when folks are getting started, before they get to that point, they're doing something like, say, let's figure out 10 scenarios that we want to create that we should be able to pass and that we want to make sure that we can run and everything goes well. And like ideally, like everything just passes all those and it's just like a check that's in place. Yeah, and it's just running. But a lot of the time it doesn't pass, right? And then you're like, good, we caught this already. Yeah. And it could be like, let's black hole a service. That's an example, right? Let's make this service unavailable, a third-party dependency. Does our whole system crash? Yeah, like a lot of the time it does.
It does.
You want to check that out before you go to prod.
Yeah, absolutely. So for teams who want to adopt or start doing chaos engineering, apart from just building good tooling and trying to make the systems more resilient, it also requires a cultural buy-in where they want to buy into the entire idea of kind of breaking things on purpose to try and make them more resilient.
Yeah.
So for teams who are early in their journey of just testing their systems like this, do you have any words of advice?
Yeah, definitely. Something that I think is good. Yeah, there's like 3 areas to focus on. The first one to me is helping educate folks on what is chaos engineering and sometimes like what is reliability engineering, like what even is SRE. And you've got to do that first, like so that people understand why we're doing this work. Then the next step to me is like trying to figure out like how do we move towards a culture of reliability where we're injecting failure. And a lot of the time for that, I would say you want to think about, are we going to do this as like a centralized team that's doing all of this work, like all of this chaos engineering work? Or do we want to do it more like self-service where we just make it available to everybody? And those are like 2 really different strategies. And then if you're like, okay, we pick centralized, you got like more control over it. You can help guide folks and you could do the work. But if you're going with self-service, then I think what you want to do is really think through other things. Like you need to build like a wiki and you need to make a lot of things like much more accessible and available to folks, like little videos or tutorials to get your team members ramped up and started. That's like my main tip there.
I see. Have you seen like differences in making it more self-service versus kind of running it centrally?
Yeah, definitely. So I've seen lately a lot of folks moving to more of a self-service kind of practice of chaos engineering, especially when they're integrating into CI/CD. So it's like, yeah, we want you to pass these scenarios. If you don't pass, here's how you can rerun it yourself on your service and make sure that you understand why your service isn't passing and what's not working well. Because I think like, you know, I worked on a build team for a while and a lot of the time people were like, why didn't my code pass? Like, I'm so mad that didn't pass. It's like, okay, well, we got to figure out why. Like, you know, that's like diving into it. But sometimes it's not clear because the tests aren't clear. Like, it's like, what does this test even test for? Like, who wrote this test? I always think through like, should this test even be here? Is this a really old test? Like, is it relevant anymore? There's just like a lot of issues with that. And so with this, you want to make it as easy as possible for people to reproduce the test that you ask them to pass and then to understand like how to be able to fix that issue. So that's like what this whole idea of self-service is. It's like sort of like get out of the way, give people tools, give them education and enable them to like uplift and build like more reliable services themselves. But you have to continuously be guiding them. So there has to be that team that's like, doing the work to like help figure out what are the scenarios we need everyone to pass? How have they changed? Like what new types of failure do we want to inject? Like what new systems are we going to be using in the next few months? Doing more like high level strategy work too. Yeah.
Yeah, that makes sense.
We're getting close to the end of the chat, but this is something that's super cool that I wanted to make sure we touch on. So we saw that you're the co-founder of Girl Geek Academy, where the goal I think is to teach 1 million girls like technical skills by 2025. We would love to learn more about it. How did all this get started?
So yeah, this is a really fun thing. I started off doing this work in Australia really long time ago. So like while I was in university, studying computing, my lecturer, she was really cool, the head of computer science faculty, Ruth. She said, "Hey Tammy, do you want to help more girls study, technology at university?" And I was like, "Yeah, that sounds fun." And so then she gave me like a project to like run kind of like a day at university for high school students. And I just thought it was really cool. Like I'd never thought of doing that before, but it was really fun. It felt great to like help them all learn, and they had a great day. And so then when I moved to Melbourne, I started to go to some meetups, like there's one group called Girl Geek Dinners. And I liked that it was like fun to meet other women that were in tech, but I'm like super nerdy. So I was like, I want to do like hands-on stuff. Like I want to build things. I want to learn new languages or new technologies or new platforms, whatever it is. And then I asked some friends, like, what do you reckon? Should we build our own group and make it more like workshops and hands-on stuff and do hackathons and do like whatever we want to do? My friend's like, yeah, I want to do 3D printing. And I'm like, sweet, let's do it. And so we've done some super cool stuff. Like we had one weekend it was like a maker sort of weekend. And we had like a 3D scanning machine that scanned your whole body. And then you could like print yourself out. Like we were doing like really fun stuff like that. But we're just like, let's do whatever we want to do. Why not? There's no rules here. So that's why we created that. And we've just helped so many women and girls over the last few years. So it's been really cool, and all over the world as well. And we've worked with a lot of great companies too. Like Microsoft has been like super supportive of our work. We do a lot of workshops with them, classes. If you go to Girl Geek Academy, there's like some Microsoft partner classes that are coming up actually, like really soon. And so, yeah, it's just a ton of fun. I've met so many awesome people through that.
That's awesome. Do you find it difficult to balance? Is there like a lot of work to sort of balance it with the full-time job, or it's...
No. So yeah, Girl Geek Academy has like a full-time CEO, Sarah, my friend. We asked her, "Hey Sarah, will you be the CEO?" She was like, "Yep." And so we got funding from the Australian government to run it. We got like our first grant was $1 million. So like it's really cool. The Australian government really cares about this and like was happy to back it with money. So yeah, she's been able to do that for the last like 6 years. It's a full-time job, and then I help out, but I don't really have to do that much work. So it's like, it's good too, you can, like, it's kind of like my tip is like, if you have some things you want to do, think of like what your ideal dream life looks like, visualize it first, like we talked about, and then just make it happen. Like, yeah, and that's it. And then you do it.
That's awesome. So the fun question that we like to end on is, what was the last tool that you discovered and really liked?
Oh, that's cool. So lately, the main thing I've been looking at actually is load testing tools. So I'm currently looking at a lot of different tools like Gatling, Neotis, Neoload, Locust, and JMeter, kind of like comparing things. So I think like Gatling, very popular, and a lot of people like that. And it's interesting too, because the reason why to look at load testing is like you obviously want to be able to like, make sure that you can simulate load on your other environments like staging or something like that when you're doing your chaos engineering work. So yeah, I would like check out those different tools. Like JMeter's, been around for a really long time. But then there's newer things like Neoload that are becoming more and more popular. So yeah, that's what I'd say. Check that out.
Awesome. And anything else you'd like to share with our listeners?
Thanks so much for listening. And if you're interested in SRE or chaos engineering, you can find me on Twitter. I'm always happy to answer questions. My Twitter handle's Tammy X Bryant. So yeah, that's me.
Awesome. Thank you so much, Tammy, for taking the time. Really appreciate it.
Thanks for having me. It was fun.
Hey, thank you so much for listening to the show. You can subscribe wherever you get your podcasts and learn more about us at softwaremisadventures.com. You can also write to us at hello@softwaremisadventures.com. We would love to hear from you. Until next time, take care.